Hello my friends, I'm making my 10th video of today. It's on implicit differentiation. I invited my son to stay and learn about implicit differentiation. I'm noticing that my desk has gotten really kind of crazy around here. I've got like 5 drinks going. Tea, water, I had to have some Coca-Cola earlier. And so something I don't allow myself very often, and it's kind of made me talkative, so I better get going on this video before I get too crazy. 2.6 is on implicit differentiation, and that's a mouthful, isn't it? And implicit differentiation is used to find the slope of the tangent line for a curve that you may or may not be a function without first solving for y. If you can solve for y, then it's probably a function if you don't have plus or minus on the other side anyway. And so something like this. I mean, can you imagine solving that for y? Well, friends, it's not possible, right? So my calculus doing friends, you're not going to be able to solve that for y. But what if you wanted to find the slope? I mean, Desmos will graph that thing. And what if I wanted to know the slope at a given point? Like x is 1, y is 1, I think is a point on that line. Am I right? Because that would be 1, that would be 1, that side would be 2, that would be, yeah, 1, 1. What if I wanted to find the slope at 1, 1? Well, I would be able to by finding the derivative using implicit differentiation. So I want to show you first some out of context practice. So I know I have 2 sides here, and I know I don't have 2 sides here, but I just want to take the derivative of y with respect to x, just so that we can practice that a little bit. And so let me get a pencil so that I can do that. Well, we have been doing this, right, all the time, right? We said, well, the derivative of y, right, when we were solving before, we had, I asked you y equals sine of x, right? Find dy dx. That's dy, right? And we said, what's the derivative of this? Well, this is dy dx. Well, what's the derivative of this? Well, it's cosine of x, and now we're done, right? And so we have been taking the derivative of y over and over again. And what the derivative of y is, when you're taking the derivative of y with respect to x, is dy dx. Another way of writing it would be y prime. But right now, I want to practice writing it this way, okay? So what if I wanted to find the derivative of y squared? Well, I would have to then use the chain rule, because I only know the derivative of y. I don't know the derivative of y squared. So the chain rule would say the outside, which is something squared, and the inside is y. And that's cool, because I know the derivative. Where'd my square go? I know the derivative of y. Do you guys remember what it was? It was dy dx. So what's the derivative here using the chain rule? You bring the 2 in the front, right? Raised to the first times the derivative of y, which is dy dx. And remember that when you use the chain rule, you do the derivative of the outside evaluated at the same darn inside. So this is y. And that's not y prime, that's y to the first. So this is 2y dy dx because of the chain rule. All right, so just taking the derivative of y to the second. So if I'm going to do this one here, right, I'm going to first take the derivative of y to the 5th. So what if I wanted to take the derivative of sine of y? Well, chain rule again. And don't worry, you can get too lazy for the chain rule once you see the pattern of what's going to happen. So the outside is sine, right? And the inside is y. But good news, I know the derivative of y. It's dy dx, right? We've been doing that over and over again. And I know how to take the derivative of sine. It's cosine of the same darn inside, which was y, times dy dx. And it's very important, that's multiply, right? And you don't have to put a time sign there, but it's very important, that's multiply. I don't have to write a time sign. The reason I'm saying that right now on the chain rule is that if I had a penny for every time that someone changed that, usually to plus, but sometimes to minus, instead of multiply. I'd be so rich that I would be living on do you want to live on a deserted island or an island with a lot of desserts? I think an island with a lot of desserts is where I would want to live. So the idea on how to find, and so just one more thing, I'm sorry, I didn't say this. When you solve for y, then that's explicit, and so instead of implicit. And so we're not going to be able to solve this for y. So that's why we're going to have to use implicit differentiation. And what that means is that you take the derivative of both sides with respect to x, treating y as a differentiable function of x. In other words, using the chain rule the way that we were practicing here. And then you solve for y prime or dy dx. So that's what we're going to do. So when you take the derivative of this side and the derivative of that side, it's the take the derivative of the pieces is what you do. So I'm going to take the derivative of this. And so my thought is, well, it has an outside of raised to the fifth and an inside of y. And I can do the outside, that's 5, the same inside, times dy dx, right? Once you have the pattern of how you find the derivative of something like this, and you can come up with your own little shortcut on it, then you don't have to think that anymore. And pretty soon, and if we were in class, someone would already be screaming it out. And so, so you might be screaming it at your TV, I hope you are, or at your computer screen. Now, this right here, I have to use the product rule because that's a product between two things. So u equals x squared, and I know the derivative of x squared. It's 2x, right? And v equals y cubed, and that's where I didn't know the derivative of y cubed, right? I knew the derivative of y with respect to x. And then we just learned this technique of finding the derivative of y to the fifth and y to the second and sine of y. And so are you guys ready for the shortcut? Do you guys know what it's going to be? Can you see what it's going to be here? Yeah, 3y to the second dy dx, right? So we had already learned how to find the derivative of x with respect to x. It's just simply, for this is 2x, right? Power rule. But when we take the derivative of y with respect to x, that's what's different, right? We need the dy dx on there because of what the derivative of y is, right? And so you wouldn't do that. That would be silly, like to separate it for x squared. But people always are like, why are you treating x different than you treat y? Well, x is different than y, that's why. Well, if I wanted to do it with an outside and an inside, here's the outside raised to the second, and here's the inside, right, x. And so this would be 2 raised to the first, same darn inside, so 2x raised to the first. And then what's the derivative of x with respect to x? Well, it's 1, right? And so that's why it's different. What was the derivative of y? We've been doing it over and over again. Well, it's dy dx, right? So this is 2x times 1. So that's the reason that, you know, x and y are different, and it's what I'm taking the derivative with respect to. So now I'm on crisscross applesauce, right, because it is product rule. So this times this. Now you're okay to say product rule u times v prime plus v times u prime. I'm okay with that, but that's not how I do it. I do it as a pattern. Multiply these together. So that's 3x squared y squared dy dx plus this times that equals, and then now I'm on the other side, finding the derivative of a constant with respect to x. And do you guys remember the derivative of a constant was 0, right? So the derivative of 1 is a constant, is 0. The derivative of this, well, I'm going to have to use the product rule again. So u equals x to the fourth u prime is 4x to the third. That's the power rule. And you guys got to prove the power rule this week, right? And v equals y. And oh, that's my friend. I know the derivative of y. We've been doing that over and over again. It's dy dx, right? And then crisscross applesauce product rule. Multiply these together. So this is plus, right? It was plus. I had to make sure I didn't get a sign wrong there. So this times this. Okay, so we would be all done with this problem, except for they asked us to solve for dy dx. And you see dy dx, maybe I'll use my pink highlighter pen. You see dy dx on both sides of the equation. And so how you solve for something like this is you got to get them separated. That's what I tell my beginning algebra students. And what are we getting separated? Terms that have dy dx on them from terms that don't have dy dx on them. So this doesn't have dy dx on it, and this does, and that doesn't. And I want to get all the terms that have dy dx on them on one side of the equation, and all the terms that don't on the other. And so that's, I tell my beginning algebra students, there's the strategy, right? There, when you're trying to solve, use the distributive property. Well, there isn't any distributive property here. Combine like terms. Well, if there were like terms, I would combine them, but there aren't any like terms there either. Then get what you want to solve for on one side, all the terms with that on one side, and on the other side, all the other terms. And that's use add and subtract to do that. And that's the get them separated step, right? So all I can do when I'm trying to get them separated is add and subtract terms from each side of the equation. So I want to take away 2xy cubed because I'm going to leave all the dy dx's over here and line it up with whatever you want. It doesn't matter. It's not like terms with anything. I guess it's like terms with 0. If you wanted to line it up with the 0 and put it there, it doesn't matter, right? And I'm going to take away this. And I can line it up with this because this is 0 and gone. So I'm going to line that up with 0 as well. I usually don't write that. I don't even write them. I just move them, right? And but I felt like I needed to write it. I'm not sure why I felt like I needed to write it, because I'm on YouTube instead of on at my in my classroom, I guess. I don't know. 2xy cubed plus 4x cubed y, right? And then over here, what I want to do is I want to factor out a dy dx. And they all have it. Now they might have other things in common besides just dy dx, but since I want to solve for dy dx, that's all I want to factor out, even if they have more things in common. And so sometimes when I'm factoring out the greatest common factor, then, I want to get other things as well. But this idea actually is not to factor out the greatest common factor. The idea here is only to factor out the dy dx. Then you can put your finger on dy dx and divide by what you see, and then we've got it solved. Other than if it would reduce, we should reduce it. So I'm going to divide by that, I'm going to divide by that, and have it. And I'm looking here and I'm seeing that I could factor in the numerator out a y and an x and a 2, actually. And in the denominator, well, I can't factor out any, they don't all the terms don't have x on them or y on them. So I can't factor anything in the denominator, so there's maybe no reason to do it in the numerator. And so I'm just looking to make sure that wouldn't, because I could make it if I separated, I might be able to get a 3, a 5. No, a 5 would only make, so I was seeing if I factored this, would it maybe become the binomial that's there if I factored out, and the answer is no, it would not become the binomial that is there. Am I sure of that? Yeah, I'm pretty sure of that. I don't think I can factor that. You might be thinking, Well, if you were thinking of how you could factor that, what might, I mean, I think it might be possible to think about it. I just don't think the numbers work out, because 5y squared and y squared, and this could be x squared and x squared. So you can see that I can make the middle term, but I don't think I can make the 3, right? Because you have numbers 5 and 1, and even if you subtract them, you're not going to get 3. So if that had been a 4, I think I could have factored, and it might, gosh, it might have reduced with that top up there. Okay, so I'm going to leave it. I think it's good. So we did a lovely job on it. You should always reduce. And so always reduce is very important. So here they're asking me to find the equation of the tangent line at the given point. And I actually graphed that curve. There it is right there. I didn't graph it. I should have said I graphed it by hand by picking points, right? No, I had Desmos graph this. And so Desmos is pretty good stuff. And so they're asking me to find the equation of the tangent line at the given point, which was pi over 2, pi over 4. I'm actually going to go put that point real quickly on the curve. So pi over 2, that's 3.14 over 2. That's 1.57-ish. And so here's 1, and here's 2. 1.57 is right here in the center. Then they said the y value was pi over 4. So I get my calculator, but that's around 3/4, right? And so 3.14 divided by 4, which is 0.785. And so I'm over here, and this is down, but this is up. So this must be the point that I am trying to find the tangent line through. So I am trying to find the equation of that tangent line. So you can kind of imagine it, right? So there, now my ruler is getting close to being the tangent line. I'm trying to make it perfect, right? So there's my ruler becoming very close to being the tangent line. They want me to find the equation of it. So in order to find the slope of the tangent line is y prime, right? That's m tangent, which is the same as dy dx. So whichever you want to call it, any of those, right? And so I want to call it dy dx for right now. And so I'm looking at, well, can I solve this for y? I can divide by sine of 2x, but I don't see how that makes it better. It doesn't solve it for y because this still has y in it over here. And you can't divide the sine and the cosine because they don't have the same angle. 2x and 2y aren't the same, so that's not if you divide it, it's not some kind of cotangent or anything like that. So I think leaving it alone the way it is the best I can do. On this side, I have to use the product rule, u equals y, and I know the derivative of y, it's dy dx. We've been practicing that. And I also know the derivative of sine of 2x, right? And so I am up here in my thoughts. My thoughts are, hey, chain rule. There's an outside function of sine and an inside function of 2x. So when I take the outside function of sine, I get cosine of the same darn inside, multiplied by the derivative of 2x, which I learned the derivative of 2x, right, is just 2. And so now that's my strategy, that's my thought right there on how the left-hand side is going to look. So I'm going to multiply these together, and I don't want to write it silly, right, when I multiply them together. So I'm going to put the monomials together. Y and 2 are monomials, so I'm going to have 2y cosine of 2x. Maybe I'll put parentheses around the 2x. And then here I'm going to multiply those together plus sine of 2x dy dx. And then on the other side, I'm going to have u, which is x, and I'm going to have v, which is cosine of 2y. And I'll do the hard one. That's 1, right? Haha, I'm just kidding. And you do this easy one. Well, it's the same thoughts, right? We have an outside that's cosine. We have an inside that's 2y. And the good news is we know the derivative of 2y. It's 2 dy dx, right? And so anytime you have y. And so, so what we're going to have here for our inside, the derivative of sine, right? The derivative of the outside is negative. The derivative of cosine is negative sine of the same darn inside times the derivative of the inside, which is 2 dy dx. And now crisscross applesauce, right? Multiplying this together with this. And I don't want to write it foolishly, right? That negative is a monomial, the 2, right? And so I'm thinking negative 2 times x. So I'm going to have here negative 2x. Then I'm going to write my sine of 2y. And then I'm going to write my dy dx. So I don't know who made me feel like monomials should go in the front, then your trig function next, and dy dx should go last. I don't know who that was. If that was you, Mike Moretti, my calculus teacher, then thank you, because it really does help when I don't write things dumbly. When I write things all in a like that, all in a crazy mess, then it's hard to solve. And so I'll tell you thank you for telling me that it's better to write monomials first and trig functions second and your dy dx last. Makes it nicer. It's even nice if you have a habit of, do you write sine first or cosine first when you have them. And so it's helpful. And so for whatever reason, I always think you should write sine first. And so, and it is helpful to have a habit of how you go. So this is 1 times cosine of 2y. That's my input, 2y there. And I have to solve for dy dx. And I can do it in general, and then I can go plug in. Or I can plug in right now. Because remember what they told me? I've now already taken the derivative. They told me that x was pi over 2. And they told me y was pi over 4, right? So everywhere I see x, I can put in pi over 2. And where I see y, I can put in pi over 4. And so this is, and if you're like tricky person, you could have put that up in your table, right? And then you could have done your crisscross applesauce with numbers. I didn't do that this time, and I don't have room. And since I've done some circling, I didn't do the circling here. Here I do my crisscrossy applesaucey, but I don't know. I'm going for it here. So I have 2, and I have pi over 4. And then cosine, and then 2 times pi over 2. So 2 times pi over 2. The 2's cancel, right? This is cosine of pi. Plus, I'm coming back on that. Do you guys know what that is equal to? If you do, write your trig teacher a nice email saying thank you. If you don't, then we need to have a boot camp on trig. So we had a boot camp on factoring that we're still working on, but we need to have a boot camp on trig. So then we're going to have here sine of, well, were these both 2x on this side? They were. 2x. And remember, x was pi over 2, so this is sine of pi dy dx. And if you know the sine of pi, then hallelujah. I'm serious. Write your trig teacher a nicely worded email saying thank you. 2 times pi over 2, right? I don't know why I didn't fix that up right there. I'm feeling like, well, I should. That's just pi over 2. Maybe I'll fix it up in my next story here, because like I fixed those up, right? So why did I do it like that? I don't know. 2 times pi over 2, right? So that was pi. I was already doing that before. And then sine of, and then this is 2 times pi over 4 dy dx. And I am going to fix that. I'm not going to be able to stand that. 2 times pi over 4 is pi over 2. The reason is because I don't want to take too many steps because I'm tired and hungry. And multiplying, you know, two fractions together. So I'm like, that's pi, right? Okay, I got the dy dx here. We're gonna figure out what that is. If you know what that is, think a trig teacher. Don't think me. I never teach trig. 2 times pi over 4. And right, pi over 2. So we already know that. So let's put that in here. Okay, so I have these memorized. The cosine of pi is -1. If you don't have them memorized, for now, we're going to do a trig boot camp and help you get it memorized. Make sure your calculator is in radians and not in degrees. So that R stands for radians. And then I'm going to put in the cosine and pi's here at the bottom of pi. This takes a lot of time just to put that in, and it'll make it where if you don't know this and you had to take 5 minutes to do it or 3 minutes to do it or whatever, times all of these, that you won't be able to finish your tests because you don't know your trig well enough. And that happened to me until I had to be convinced that I need to know my trig better. And so I had to teach myself my trig because I didn't know my trig. And so if you're in the same boat, then you're going to need to teach yourself your trig as well. And so I'll help you. We'll do a boot camp. So this is pi over 2 times -1. So this is negative pi over 2. Now the sign of pi, you should know that's 0. And so you shouldn't have to take the time to make sure that it's 0, but it is. It's 0. So 0 times dy dx is 0. So this is plus 0, so no reason to write it. Is that okay? 0, 0, right? Okay, then over here the 2's drop out and I had negative pi. What is the sign of pi over 2? And that's one you should know as well. It's 1 you should know, I say. 1 that we should know. So let's see if we know that one and see what we get here. And so it's 1, right? And so this is negative pi times 1 times dy dx. So this is negative pi dy dx. And then cosine of pi over 2 is also something that you should know. I'm going to be careful not to say it's 1 you should know because that's not what it is, right? And so what do you guys think it is? And so I'm hoping you're saying 0. And it is, it's 0. Okay, so this is what we have, and we're supposed to try to solve for dy dx. So all I have to do is divide by negative pi, right? So I have negative pi over 2 divided by negative pi, right, equals dy dx. And if you needed to, I guess you could do that in your calculator, but the pi's drop out and a negative divided by a negative is a positive, so this is half. So it's pretty nice that the slope here is half. And I don't know if I would have guessed that the slope was half. I could draw it in there definitely, and we will be drawing it in here in a second, and we'll be seeing if we agree. Now they asked us to find the equation of the tangent line, and I'm going to have us put it on there too. So I have it, this is the slope of the tangent line. It's real important that you follow the directions. I often have people on a test, tangents, I'm talking at the same time, slope of the tangent line, and they'll be asked for the equation of the tangent line, and they'll only give the slope of the tangent line. Or they'll be asked for the slope of the tangent line only, and they'll go further and find the tangent line, the equation of the tangent line. And that's not necessary. That's not what they asked you to do. And it kind of shows that you're either carelessly not paying attention to the directions or that you're not sure what they're asking you to find. And so, in either way, that doesn't look good, right? And so you want to be careful, what are they asking me? So here, they asked me to find the equation, so I'm going to say the equation of the tangent line. And so I needed the slope, and now I know it. Slope of the tangent line is half. And I needed a point, which they gave me, pi over 2, pi over 4, right? And so this is my x1, y1 to fit into my formula. I use this formula because this is the formula that they use in the book. If you have another way of finding the equation of the tangent line that you learned in your algebra class that you like better, I'm cool with that. And so I'm using what they use in the book, whether I like it better or not. And so so I guess I'm not giving my opinion of which way I like better. And maybe which way I like better depends on my mood. I always like ice cream better than, well, not better than pie though. I love pie. I don't know. So it turned out pretty nice because those went away. And my equation of my tangent line, right here is the equation of the tangent line, is y equals 1/2 x. So if I wanted to plot that, well, I already have a point. Remember, the tangent line and the point that you were on your curve, they should have that point in common. And so I already put that point that they should have in common on there. And you can verify that that's the same point, right? That x is pi over 2 and y is pi over 4. Half times pi over 2 is pi over 4. Yeah. And what other point goes through this? Yeah, if x was 0, y would be 0. And 2 points determine a line, and that's certainly 2 easy points that I have there. And so now I can draw the tangent line on here. So beautiful. My tangent line drawn on there. So there's my tangent line. Okay, so we did a lovely job at that. Does that seem sort of okay? Okay, and I added the part about doing this and put the graph on there because I like to kind of know what I found. Definitely, I could have done it without doing that, right? I mean, I could have done this work without doing that. It was a lot of work on that problem. And this problem here is even gather your strength for this one, I think, because it's asking me to find the second derivative is what it's asking me to find. So that means find the first derivative and then find the derivative of that. And so we're going to find the first derivative and then we're going to go find the derivative of that. And yes, my camera is getting, well, my camera is really, really, really old. It's not older than you guys are. My car is older than you guys are, but not my camera. And so it's starting to, my computer is also having problems. They're both thinking that Zoom, recording, and all of these things for hours upon hours a day is too much for it. My computer was overheating, and so I put it in the bathtub to cool it down, and so now it's doing a little better. So let's see here. It was running a fever, right, when you're overheating. Taking the derivative of x squared, well, this equation can't be solved for y. Do you guys agree? If it could be solved for y easily, I would be solving for y. You might say, well, I can solve it for y. Well, you have to get pretty tricky to solve it for y. You could use the quadratic formula to solve it for y. Then it would look really nasty. And you would have to get this, you would write this first and this second, and your coefficient, and then you would write this third, these things third, with 0 on one side to use the quadratic formula. Did you guys do that in pre-calculus? Oh man, that's a freaking hard problem, right? And it gets so nasty, you know, with your negative b plus or minus the square root of b squared minus 4ac divided by 2a, that there's no way that we'd be able to find the derivative of it. And it has a plus and minus in it, and we haven't learned what do you do if you have trying to take the derivative of a plus and minus, right? Oh my goodness. It would be, wait, piecewise defined maybe, right? I mean, my goodness, what would it get, right? Well, we can avoid all that. All you have to do is use implicit differentiation, which means don't solve for y, just take the derivative of the pieces. Now, a real common error that people do, and I know that, I mean, I kind of interview people when there's a common error, and I found that it's they haven't practiced much. And that is they go like this, y prime equals, and then they say 2x, right? Well, no, right? Well, we didn't have y over there, right? And we have equals, and we have 3 on the other side. So that that is just, well, that's habit from that other section, right? Where we had it solved for y. Well, we haven't solved it for y. So you're going to take the derivative of this piece and put it straight down. That's 2x. You're going to find the derivative of this piece. Well, the derivative of this piece, it's not tricky hard, but you do have to use the product rule, right? U is x and u prime is 1. V is y, and the derivative of y is dy dx. And yeah, I know you could probably do that in your head, right? You get where you can do it in your head. Here's what happens to people is that they do things in their head and they get it wrong. And then they're like, why didn't I get any partial credit at all? Well, if you do it in your head and you get it wrong, I have no idea what you did. So if you write out what you're doing, then I can at least try to give you partial credit. So that was me here taking the derivative using the product rule for this piece. Now this piece, all I have to do is use the chain rule, and you probably have gotten where you're no longer thinking the outside is something squared and the inside as y, so that this is 2 times the same inside, y to the 1, right, times dy dx. You're probably not writing it like that now. You're probably, hopefully, just writing 2y dy dx. You probably have come up with a way of thinking about it using a shortcut other than the chain rule. Equals, and then the derivative of 3 is a constant, which is 0. And so I don't want to try to take the derivative here. I want to first solve for dy dx, then take the derivative. That'll make it easier. So remember how we did before? We got all the dy dx's on one side and the other stuff on the other. So I'm going to subtract that stuff to the other side. So I'm going to be taking away 2x, taking away y. So I'm going to take away 2x, and I'm going to take away, not 2y, just y. And I'm going to leave on this other side, so minus 2x minus y. And on this side, I'm going to factor out. So this is gone, right? I just moved it over there, and that's gone. And I'm going to factor out a dy dx. And then I'm going to divide it to the other side over there. Put your finger on dy dx and divide by what you see. I put my finger on the wrong thing because I'm tired and hungry. And so I thought that these were going to cancel. And I was like, when I thought they were going to cancel, I was like, hot diggity dog. And then I was like, oh, they don't cancel. Do they? Okay. So that's the first derivative. They didn't really ask me for that, but I am going to put a box around it and trying to watch my time because I have a dinner engagement, a dinner date, so to speak. And so so if I'm going to take the derivative of the derivative is the second derivative, right? And a lot of people ask me about this notation right here. But that's the second derivative of y with respect to x twice, is I think some people say like that. And so because you notice the 2 is not on the same piece, right? And so anyway, and so here I'm going to find the second derivative. So I'm going to take the derivative of this. So that's d. I'm going to write that out. And then to take the derivative of the other side over there, it is u equals negative 2x minus y. I could have factored out a negative 1, and I think that then probably I would made a sign error shortly after doing that. Because see how it's easy when it's a piece, but then if I had factored out a negative, I'd have a product. Negative 1 times that stuff, and then I would have a more difficult time finding the derivative here. So this is just x, so this is just minus 2. This is y, so be careful, that's minus dy dx. And then this is x, so that's just 1, and that's y, so that's plus 2 dy dx. like all my colleagues in my class, I remember when I was learning calculus, like got the idea of taking the derivative of y way faster than me, and we're saying, just treat it like it's x and hang dy dx on it. And I was like, oh, yeah, that does work, doesn't it? Now it's quotient rule, so I have to start down here. I'm going to multiply these things together, this one and this one, right? To me, it's a pattern. I don't write out the formula, so I don't write this minus this over that squared, but I have memorized the formula. But to me, it's a pattern, and I say to myself, I start in the bottom here. Is it important that you start in the bottom? And the answer is yes, because subtraction isn't, what is that, commutative? Subtraction's not commutative, and you're going to subtract this. You're going to go this minus that, and it's different if you do this minus the other. And so, and it's huge if you do it backwards. And so you want to make sure, so if you have to write out the formula, u prime v minus uv prime, then write out the formula divided by v squared. And so someone I like very much tells me that he has to tell himself to divide by v squared in stern tones, because he would forget to divide by v squared and then look in the back of the book and have the wrong answer. And so he was saying things that I don't like to say out loud to himself, and I don't like people I love to talk to themselves like that either, I told him. But anyway, that's another story. So be careful there. And so this is x plus 2y quantity squared. Okay, what a mess, right? Do you guys agree with me that that's quite the mess? And I hope that you notice, I mean, this is going to become like the algebra nightmare of your life right now. If you were in face-to-face class, I'd tell you run for it, right? Just pack up your bag and run for it. But since you're on YouTube, what I'm going to say is pause and get your courage up. So dy dx is equal to that, right? Which is going to put a fraction in there. So should I FOIL this out first and distribute and then stick that in there? Because I have it here too. And the answer is, well, whatever I do, it's going to be bad. So, so just go for it, is what I'm going to say. So this is going to be minus 2x. I'm going to multiply it together. Person who's doing its choice, right? You can do it differently and compare what you have to what I have. Hello, my friends. I had a little algebra problem. I FOILed this and I FOILed that, and I got the next line perfectly. That was okay, but when I carried down, I got that, and it got crazy then after that. So I'm just gonna start again. I probably wouldn't even had to admit it to you. If we had been in class, I know you guys would have saved me. You would have helped me. So now, and then I did the video again, and I was writing all along, and because I had so much up here that I was still showing like this, I was off here, off the page where you could not see me writing. So it's been video number 10 has been kind of hard. It's been kind of rough. So you're like, well, we don't have 10 videos. Yeah, but the algebra class does. So anyway, okay. It's going to be okay. Stop complaining, right? Doesn't help. Doesn't help to complain. Not at all. Just be happy. So I'm going to do it right this time. That's what I'm going to be happy about. So I'm going to have minus 2x. I'm not going to carry down anything wrong. Minus 4y and minus x dy dx. And minus 2y dy dx. That was the term that got me before. Okay, and then I'm going to put the minus, and then I'm going to go here. I'm going to be careful there because, well, I was already careful, and it still got me because of a carry down, because you can do that here. Minus 2x minus 4x dy dx, so I am foiling, minus y minus 2y dy dx, all over this. And then I notice with joy, right, that negative 2x, and then when I distribute that, that would be plus 2x. Do you think I should do that? Or do you think I should take another step? What do you guys think? Okay, for those of you who think I should take the extra step and write it out, I'm doing that. For those of you who don't, give a little fast forward. So this is 0. This is minus 3y. This is plus 3x dy dx. And this is 0. So we have this. Not going to get myself off the screen. Now here's the thing, is dy dx has a value. Do you guys remember what it was? Right here. And so we need to plug that back in for what the value of dy dx is. So minus 3xy plus 3x, and then times, right? And then this fraction, minus 2, what was it? Minus 2x minus y, all divided by there we go. Okay, so now I have a complex fraction, and so I need to multiply by x plus 2y. And so sometimes I think it's helpful for people to realize this is a term, and this is a term, right? That's what I have in my numerator of this fraction here. And I'm going to multiply by the common denominator. So I'm going to multiply right here in the top times that denominator, x plus 2y. And I have to do the same to the bottom. Okay. And then I'm going to distribute this. This is going to multiply. This thing right here is going to multiply times that thing, right? So this is going to become minus 3y times x plus 2y. And yeah, I'm going to multiply it, but I've chosen to wait and multiply it in the next step. If you're like really clever and you're thinking that you haven't already made a mistake on this, you could do it now, fast forward, you know how that goes. And so I'm going to multiply here, and when I do, those cancel, and that was the plan, and leave just the 3x times the binomial there. So plus 3x times the binomial there. And in the denominator, I have 2 of them, I have 1 more of them, I have 3 of them. And then now things are looking okay. So I'm going to have negative 3xy minus 6y squared minus, I think, 6xy, and that had an x on it, and I lost the x on it. And so this was, here was this, here was this, here was a boo-boo all together, and here was here. I think I've had enough math today. So the algebra has just gotten tremendous on this, and it's gonna get the answer is like so amazing that you guys will go crazy. You should write this in descending order, and what descending order is whichever one's in the alphabet lower, which is x, and the highest exponent of x, which is x to the second, because that's x to the first, and this is no x, which is x to the 0. So minus 6x to the second. The reason that you write it in descending order is that's the only shot you have, or the best shot you have, of factoring it, you know, the F word, factoring it. So I am going to factor out a negative 6, and I actually was thinking that I sillily was thinking that that might factor and cancel with the denominator there, but it doesn't, right? But what you might notice, and it happens on many of these implicit derivative where you had to find the second derivative, that this will show its head, its ugly face, its pretty face, I guess it's pretty, in your answer. So notice x squared plus xy plus y squared, x squared plus xy plus y squared, and that's 3. Now, it would be, if you didn't know to look for it, you might not see it, but it happens on so many of them that you know to look for it. And so you will see it, and you'll be able to simplify it and make it look so much nicer, because that's 3. And then we did a lovely job on that. Algebra, right? And so anyway, so negative 6 times 3 is negative 18. So wonderful, wonderful, wonderful.